Hello, everybody. Welcome to the Architect's Edge Live. This month's session it's amazing. This is the modern VKS unlocking what's already inside your vSphere Kubernetes service, which Bryan will probably repeat again. My name is Christopher Kusek. I run the Architect's Edge Live. If you have never checked out the resources pane inside of a Zoom session, go click it. It has the link to the webinar, the newsletter that shares all the webinars. It's got Bryan Sullins' LinkedIn, my LinkedIn, and Chris Katano's LinkedIn. So you'll be able to go and find us out there in those places. I'd say let's kick this off with a little introduction on Chris Katano. Chris, do you want to introduce yourself?
Yeah, thanks, Chris. Pleasure to be here today and be a part of this. I'm looking forward to a great session. You're in really good hands with Bryan. My name's Chris Katano. I've been doing the modern apps thing here with VMware and Pivotal and Heptio and a lot of these organizations that have come together to produce something as awesome as what you're about to see today. And looking forward to supporting the effort. Thanks for having me.
And I'm going to kick off a poll around Kubernetes use cases. It's take some time, fill out the poll as you want. I'll keep it running for a few minutes. And in that meantime, Bryan, time for you to take the show.
Cool. Is this going to show up as one of those word clouds, Christopher, or no?
It is not going to show up as a word cloud.
That's a bummer. All right, cool. All right. Well, participant number go up. We'll just get started with the preliminaries. Yeah. Hi, I'm Bryan Sullins. I am a senior solutions architect out of the Seattle area. There's my email out there for everybody. One thing I wanted to do is I typically try to file a receipt or two before I get started. I came from the customer side. So I've been at VMware Broadcom for just over 3 years. But before that, I actually did this. I actually ran Kubernetes. I was a platform engineer at a large retailer that isn't Amazon. You can see my LinkedIn there if you want. But for about 4 years, I ended my career out in the field as a platform engineer. So I did all the DevOpsy stuff, Kubernetes, and so on. So I feel like I can hopefully contribute and put stuff out there for you to find valuable. So off we go. I want to level set with trying to get everybody into the psychology of thinking of VMware as a private cloud, because that's going to set the stage quite literally for everything else we are going to be talking about throughout the rest of our hour here. And I've decided to kind of put this, or the context that we're getting into, is myth busting. And this is based on literally the customers that I talk to day in and day out. So I'm I'm a solutions engineer. So I'm on the front line selling VCF as a cloud platform. And I just hear a lot of these different myths, and a lot of these are based on literally things that customers say to me when I sit across from them at the table or at Zoom calls. And some of these are paraphrased, but myth number one is VMware Kubernetes setup is hard. And we're going to talk about, briefly talk about how to set that stuff up. An ongoing myth that I am going to bust is this whole idea of proprietary lock-in with VMware. As a matter of fact, the opposite is true for reasons that we will be talking about throughout the hour here. The other one is you can't run cloud native on VMware. I have found that this is a pretty bold opinion because words mean things. The other one, sort of a sub myth that I'll be kind of tackling at the same time, is that public clouds run your stuff on bare metal. And, we'll talk about, what it means when you run Kubernetes out in the public cloud. And when I mean public cloud, I'm talking about, EKS on AWS or AKS out in Azure. The other myth I'm going to bust is the Kubernetes on bare metal myth, and kind of compare those two. I actually have a VCF blog post out there if you're interested, out on VCF blogs officially out there in VMware. And then another myth is I've heard customers say we don't feel like VMware is a major player in the world of Kubernetes. I'm going to dispel that one as well towards the end. We're going to talk about briefly Private AI Foundation, the Tanzu platform. I might ask and put our good friend Mr. Katano on point there. And then BYO underscore or BYO anything, like as part of that. And then finally some next steps after the presentation. So excuse me. So putting into context the approach that we have now is that VMware by Broadcom is now a private cloud platform, right? We are not focusing on vSphere as the flagship product. VCF is a flagship product, and the evangelism that I've done over the past, well, ever since I've been at VMware, because we have been a cloud platform company for more than a decade. We now sell this as a private cloud platform as our flagship product. So the way to look at this is, if you take a look at what's offered out in public clouds, you can create your VMs in mere moments. Kubernetes clusters are self-service, and really, when we start talking about consumers, we're talking about platform engineers, site reliability engineers, and developers who can consume this on-prem as you would out in the cloud. So your traditional vSphere admins become cloud admins through policy-based management, which is a thing that serves all of this out to your consumers ultimately. So we're creating that same experience with those same expectations through our platform that we're implementing out there. VKS is one big part of that, as you'll see as we go on here. So one of the myths is that VMware Kubernetes setup is hard. It has now been made super, super easy. And ultimately, the Rubicon that you would cross setting this up is to install what is called the supervisor. And the supervisor is a Kubernetes cluster that provides for what we call Paravert, and that allows for all of the self-service for Kubernetes clusters out there, amongst other things. It also provides for extensibility, and it also provides for this best of both worlds, where I can run my Kubernetes containers all within the same infrastructure as I can all of my virtual machines. So the supervisor cluster is the big setup portion. Once that's done, I don't want to say it's really all downhill from there, because at that point now you have unlock all the options of creating self-service Kubernetes, self-service virtual machines, and so on. One important point also about this is that this is included with VCF. There's no paywall for additional things. As far as like a Kubernetes runtime, fully functional, enterprise grade, this is all included with the VCF product. So some recommendations and requirements. There are a few that are outside of this list here. This is really just kind of like the considerations that you would need in order to run modern VKS or Kubernetes on-prem, in this case through Enterprise Plus. vSphere 8 U3 is our modern implementation of Kubernetes through VKS. So that would be one requirement. There are your supervisor capacity requirements. This is taken straight from our VMware validated solutions recommendations for the supervisor capacity. So ultimately, these are going to be control plane VMs that run within the infrastructure. Full VCF gives you the full capabilities. You have the capability of running things that you would expect, or that developers would expect, or platform engineers or site reliability engineers would expect in an enterprise grade Kubernetes implementation. So full VCF gives you those capabilities, which is kind of the tongue-in-cheek mentioning of like, these are things that if you have VCF, and 97% of my customers have actually purchased VCF, you already have this. This is a thing that you could do tomorrow. There are some other ones too, and this is the more myth busting, because one of the myths that I hear is, oh, well, is VMware going to require me to run NSX? It's going to require me to run vSAN. And the answer is, well, we're going to, of course, recommend those things, leading to a much better integrated cloud-like experience, absolutely. But they're not required for VKS in this case. So it's recommended that you use NSX. You have some advantages. There are some deep dives that we go into to talk about, what are your pros and cons for a lot of those particular decisions. But NSX is not required, and neither is vSAN. Although, again, I'll throw it out there that, of course, we're going to recommend those for having, those sort of integrated and built-in policy management experience capabilities there. So there are a couple other things too. For example, content library, which is the thing that your typically familiar with if you're a vSphere engineer. Those are all things that they're pretty well versed in. So nothing super against the grain as far as getting up and running with the supervisor cluster. Now, as far as standing up the supervisor cluster, I would say the easiest way is to do this through infrastructure as code, which is going to be yet another theme that I'm going to be hitting at throughout our presentation here, because this isn't a situation where we just slapped a UI on top of our Kubernetes implementation. This has all of the typical capabilities that infrastructure as code developers, platform engineers, and site reliability engineers have come to be familiar with and have come to love. So as far as like, hey, I need to get the supervisor cluster up and running, it takes less than an hour ultimately. You can import a config that is based on JSON, and here's an example. These are all sample capabilities. This is it. This is the definition to get up and running with the supervisor cluster. And again, once you have that supervisor cluster up and running, you are now up and running with our VKS capabilities. Post-installation, some subtle things that I wanted to make sure got included with when we implement this. Number one, this is actually, we'll call it a production implementation that I was able to pull. But post-implementation, these are all, the supervisor cluster is a Kubernetes cluster, and it has control plane VMs that are implemented as VMs within the infrastructure. And what I'm pointing out here, ultimately, kind of the subtle nod, is the fact that you have a lot of the same protection and reliability and redundancy that you would have as you come to expect. So for example, right out of the box, you don't need to configure a thing. As long as the cluster is HA capable, these are all protected and been put across multiple physical ESXi hosts. So there's a protection layer already built in without any configuration that you would need to do on top of that. Furthermore, the additional capability that you have also is we support the capability of stretching your worker nodes across multiple clusters. So as far as like, hey, I want to also have, data center level redundancy, you have that capability as well. Oh, I know what I was going to talk about here too. Think of your supervisor control plane as a vCenter-like capability for Kubernetes. One of the big questions I get as I go through a lot of this material is, well, does that mean that the supervisor cluster is unavailable? Does that mean I can't run my Kubernetes clusters and my Kubernetes clusters are also not available? And the answer is, even if the supervisor control plane is unavailable, your Kubernetes clusters will continue to run just fine. So same kind of concept with the supervisor control plane as with other things, and you can find ways of protecting that, particularly through the strict cluster abilities we have. Post-installation of your supervisor, you can now provide for self-service within vCenter to your consumers. Remember that whole idea of I now have the ability to do this in a self-service way. And the way we do this, or one methodology for doing this, is through the local consumption interface. That is a post-installation supervisor cluster capability, which also has an ease of install that can be done through infrastructure as code, and it's a YAML infrastructure as code, and it's also a YAML import. You'll notice a lot of nods to infrastructure as code and kind of exposing of capabilities through the UI, which is something that we are doing more and more of as our product matures. But you'll notice that we have the capability of rolling out Kubernetes clusters that your consumers will actually connect to. And yes, you can do stuff as simple as, well, I'm just going to go ahead and grant our developers or platform engineers access to the kube config file so they can use kubectl to do this. It is a CNCF certified, Kubernetes runtime. So with all of that in mind, getting up and running of this is pretty straightforward. And this can be done like within an hour. Within an hour, you can actually have Kubernetes clusters out to your consumers. So myth number 2, and I've sat across from, 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 I've sat ac people who should actually even know better, where they use the phrase that workload fill in the blank needed to be cloud native, so we put it in the public cloud. Kubernetes runs on bare metal there, right? So these are things that were actually said to my face, and this is a bold opinion that I'll stand behind. So that meme of like, a bold opinion that I would stand behind and defend against the world is you can run cloud native on-prem on VMware. And the reason why is because words mean things. So whenever anybody uses the word cloud native, I typically pounce because I typically sort of ask them like, what do you mean cloud native? And a lot of times they don't mean it doesn't mean what they think it means. We're throwing memes out there like crazy in this out there. But cloud native computing or cloud native is an approach, right? Notice that private clouds are listed in here as that definition, and I'm using a vendor neutral definition of it. But people typically think of like, okay, what do I mean by cloud native? It means that you build things with a cloud approach. So a lot of people think of like infrastructure as code, automation, containers, serverless, microservices, and so on. It's declarative, right? So it's a bit of a malleable definition, so it's contextual. All I can tell you is that everything that is listed here in this bullet are things that we do, and that's super important. We do microservices, serverless, for example, ever hear of Knative? So these are all things that we actually do, and you can do them on-prem. Very, very important to make this distinction. If you're an engineer out there who is trying to make a case that you want to run Kubernetes on-prem through VKS, very important to dispel these kinds of myths, because they have this stuck in their brain that, oh, well, there's sort of inherent advantages to running things out in the public cloud that, VMware sometimes gets short shrift or passed over for. No, and we have the receipts on this. We can prove this. I've done it on VMware and so on. So all of these things, and we'll even more develop this as I go through here. While I'm on the topic, nothing architecturally different about running Kubernetes on AWS, through EKS or through AKS on Azure. Nothing architecturally different. When you create an EKS cluster, for example, and by the way, not bashing our competitors here in any way, shape, or form, demystifying them, that's different. What I am saying is that there's nothing architecturally different or advantageous about running things out there. When you create a Kubernetes cluster on EKS, that set of containers and that Kubernetes implementation runs as a set of containers inside a guest operating system on a VM on a hypervisor. When you create a VKS cluster in VMware, that set of containers runs inside a guest operating system inside a VM on a hypervisor. There is nothing architecturally different about running a thing in the cloud, in the public cloud. Okay. The only real difference is that shared responsibility model, but architecturally, no real difference. Very important, because a lot of people think that when they run things out in the public cloud, it runs by either magic and or runs directly on bare metal, and that just simply isn't true unless you specify otherwise. So why VKS on-prem? There are probably some other things that my compatriots can probably list as well, but one of the biggest ones I would say is that you can have the same capabilities, just less expensive with a better ROI and a lower TCO. And this is just an example that we've had. We have tools that we can prove this out. These are things that I've actually done with a lot of our customers to show them literally that it's actually going to be cheaper to run VCF and VKS in this case as part of that stack compared to out in the public cloud. By the way, this 0 is actually facilities. Right, just so you know, because it's a little confusing to look at that, but there you go, there you have it. So it can be more secure. One of the things and one of the use cases that we've seen in some of the sort of positive uptick that we've seen in the adoption of our platform is a lot of people don't want to put their AI models out in the public cloud. They want to actually keep them on-prem for more secure reasons. So that is another thing that we've been able to meet the call for. Equal or better performance, we just talked about that. No loss of functionality features, as you will see in some of my ensuing slides coming up. You have better governance, better resiliency through multi-cloud geo-dispersed approaches. Literally just talked about that earlier with the whole multi-cloud approach and having the worker nodes spread across multiple data centers. There are probably more, but those are the ones that I could come up with. And if you've so far been looking at your Blue Sky feed or your Instagram, and you kind of like, okay, Bryan, I get it. I'm on board with it. Those myths are dispelled so far. Awesome. You might want to take a look up and see this slide, because this one to me is a slide that can actually convince the haters, if there are any. Hopefully there aren't. But again, all of this included with VCF. If you have VCF, this is all included. You have the capability of implementing, and this is all, for example, like, hey, I need an image registry. Well, Harbor is a thing that we coded out and then open sourced, right? Those are some of the contributions that we've made, which I'm going to go a little deeper into that a little later in the presentation. Storage and data services, stuff like, database as a service, right? We have the virtual machine service. And some of the things that we're doing in our private cloud platform is the capability of, through a single API and a single interface, running your virtual machines alongside your Kubernetes implementation. Multi-cluster management through our VKS manager, multi-cluster management UI and API. All of the automation, and we have integrated our VCF automation product for that. Service mesh through Istio. So these are all pretty well-known things. And again, these are all things that when I want, for example, a developer to connect to this, or a platform engineer to connect to this, I want them to have a familiar environment that they've come to expect when they connect to any Kubernetes capability. And that is what we are providing. Identity and access control, those are all in there too. And the title of the slide, it's a mouthful, but it means everything. Enterprise grade, CNCF conformant. We're going by industry standards. We're going by the Kubernetes standards. It's built into the product and then out of the box. These are cloud services that allow for any one of these personas to have that capability. One other thing, and this is another myth also, if you are what we'll call the cloud admin, formerly known as maybe a VI admin, or you are a vSphere administrator or a vSphere engineer, as far as like to what extent you are comfortable moving up the stack, we'll call it, into like rolling out Kubernetes and learning Kubernetes, it's really up to you. So when you roll out a database virtual machine, you don't need to know databases. You need to know the specs to be able to roll that out. We are creating the same experience. And I say this for a lot of vSphere engineers who want to focus on just being a vSphere engineer. You don't need to understand Kubernetes in a deep way to be able to do this. This is a way that you can just share this out through a self-service experience, sometimes with that kubectl capability and whatnot. Or if you wanted to move further up the stack and kind of have more of a team-based approach where it's like, hey, man, I want to actually expand my career and get better at the Kubernetes things and, kind of learn from each other, you can do that as well. So just wanted to make sure that I didn't scare anybody off with a lot of these capabilities. And that is a big focus that we have here with our Kubernetes implementation. So,
hey, Bryan,
I
wanted to ask the question because it gets asked a lot. If
Sure.
I don't have VCF yet today because I haven't renewed yet, but I'm going to have it tomorrow or the next day, how much of the stuff that you're talking about am I able to start taking advantage of today before I'm VCF, or or even if I just bought VCF and haven't fully adopted it yet? Can you talk about that a little?
Yeah, so way back when we talked, that's a good question. Way back when we talked about the NSX and the vSAN not being required, right? So let's say you're kind of a vSphere only shop, and you could even go back to being like, old school vSphere perpetual onto like vSphere Plus, which is the release typically that, at least when I signed on, that's what we were releasing. It's built to be backwards capable, which is to say that if you are Enterprise Plus, vSphere Enterprise Plus licensed, then there's nothing stopping you from doing any of the stuff I'm talking about here. You would have some possible network considerations from there. You'll be really going by some kind of run-of-the-mill, CNI. So CNI, a container network interface, those kinds of things. You'll be going by what's provided within Kubernetes. Still conformant, still Kubernetes compliant, still CNCF certified. You would just move forward with those capabilities at that point in time. So yeah, there's nothing stopping you if you're a vSphere shop. That's actually a very good call out.
Did you say no NSX or vSAN is required to start doing this stuff? I feel like an infomercial, but seriously, right? Because I know that's a
That's
common
correct.
question in the chat and as well as the Q&A.
Yeah. It's not required. I'm assuming that's probably because it might be hard to believe for some people, but I can't stress enough how we have not, as an organization, let off the gas on vSAN and NSX and the innovation therein. We haven't let off on recommending that. We haven't let off on showing all the advantages you have and the value you add by actually going what we call full stack VCF with NSX and vSAN, because there's a lot of out of the box and integration capabilities that make your life easier in the long run and make things possibly more secure. For example, goes a little bit beyond what we're saying here, but as far as like, can I do this? vSphere Enterprise Plus allows for you to do these things. So yeah, really good question.
Yeah, awesome. Thank you so much for that clarification, Bryan.
Yep. So important point or important call out here. We talked about the supervisor cluster. We talked about the supervisor control plane. We talked about its extensibility. And we're moving to two other sort of myth busting topics here. One is, or really conceptually, the supervisor cluster is for you as an engineer you're the one behind the curtain pulling all the levers in this Wizard of Oz. The supervisor cluster is not accessed by your end users and by your consumers, right? What you will do instead is you will roll out a Kubernetes cluster that they will connect to that is placed by default into a single namespace. And that namespace is a Kubernetes object. And that namespace allows for you to now have this sort of multi-tenancy-like capability where it's a security boundary, it's a settings and policy definition boundary, and now you're going to roll those out and grant access to them to developers or platform engineers or however you have that all set up. Notice in this case, I've got two of them, right? I've got two different ones, and there's, you can just keep going and say, okay, based on our plan, we have these multiple Kubernetes clusters that we have rolled out there. But you'll notice that we're rolling out VMs alongside those, and we're doing this through the same API. So you have that. Anytime you see the supervisor service namespace, the service namespace is stuff like, oh, well, I'm going to run Harbor in that. So that would be a namespace that would be, quote unquote, shared amongst all these different Kubernetes clusters. Because we want to do our repos centrally, for example, right? And as you'll see later on as we go through the presentation, you're not required, just like with all these other things, you're not required to use Harbor. There's a lot of BYO stuff that we'll find out here coming up in some of the ensuing slides here. Again, if you've been having a wandering eye on your social media, this is yet another slide I would encourage that you pay attention to and kind of process, we'll call it.
Are you telling us to screenshot this right now and stare at it at our own leisure, Bryan?
I think you're saying that. It's fine. You can do that.
Sorry, go ahead.
So these target Kubernetes clusters that you're sharing out. Oops, I went back too far. Every vendor makes decisions on what they include with their Kubernetes implementation because according to the CNCF compliance, you have a certain level of expectation, like a dial tone, we'll call it, of what people expect inside their Kubernetes clusters. Every vendor makes certain decisions. These are the decisions that we've made when you roll out that particular Kubernetes cluster. So for example, you have Entrea and Calico as your CNI, right? If you are a person and you're like, nope, and I've seen the opinions on this be anywhere from, I don't care what the CNI is, as long as I have one, it doesn't matter to me, on over to like, I'm ride or die flannel. I don't know, throw that out there. We actually have these as an initial starting point. If you want to install some other CNI instead, and you're dead set on doing that, you certainly have the capability of doing that. The way I would call this, we're opinionated, but also flexible. So in these target Kubernetes clusters that people are connecting to, do you have to use this deal as a service mesh? No, but it's there if you need it. Do you have to use some of our ingress? Do you want to use Nginx as your ingress? If you want to use Nginx, you can certainly do that. You have that as a capability. Those are things that you would just simply code out in addition to this. It's not unlike any other Kubernetes implementation, but these are sort of the starting point and the additional services that we provide in an easy to install capability. And yes, you can do this through CI/CD pipelines and whatnot, all you want. So these are a lot of the things that we provide as part of the implementation. Valero, for example, is a Kubernetes aware backup utility. Do you have to use that? Well, no, but it's there if you need it, that sort of thing. So very important that, I want to make sure, and again, I'm getting back to this whole ensuring and busting that myth we talked about previously of being locked in. Not the case. It's CNCF conformant. If you want to use something else, then you certainly can through those kind of means. Yet again, on this whole idea of the vendor lock-in or sort of other sort of concepts there. When you create a Kubernetes cluster that gets placed into a Kubernetes namespace, and this is the beauty of the supervisor cluster, and this is why it's advantageous. And a lot of people, again, another myth of oh, the supervisor cluster, that means I'm locked in, right? Actually, the exact opposite is true. The supervisor actually allows for vendor neutral or CNCF certified and Kubernetes compliant Kubernetes implementations. So that namespace, if you have somebody connect to, through kubectl or whatever, they connect to that Kubernetes namespace, they're going to feel right at home with that implementation because it is a CNCF compliant Kubernetes namespace. But that namespace actually ends up as a vSphere object, which is a resource pool. So that is where we have that familiarity that a vSphere admin would know and say, oh, well, I know what that is. And you have the capability, if you go into the namespace, there's some additional UI capabilities you have in there or through infrastructure as code to be able to provide access for people to be able to, for example, manage VMs. Because remember, ultimately, a lot of these containers run, all of these containers run within virtual machines. And I need to provide a method by which those VMs are administered. And that's where we have that best of both worlds to where it's it is a CNCF conformant capability through Kubernetes. But we also have the familiar entity that we have as in this case, a resource pool. And that is pretty much everywhere to where you have, if you're a traditional engineer that you're looking at all these vSphere objects, it's something that's you're at home with, but also you have this, pervert, view of all things in Kubernetes as you would expect. So this is just one example, by the way, and there's kind of the color-coded view here. So I have my VKS Kubernetes clusters separated by those namespaces. I have various differing policies for those. So for example, in sort of the pattern with Kubernetes is that you should have a certain standardized approach. All right. We're standardizing on a thing. Our approach for ingress is the same across all of these. I see shops where they're kind of all over the place and allow for people to create their Kubernetes clusters with differing policies. That's anti-pattern. Really, the pattern is I have a decision mechanism where I go by that I decide upon and use a certain standard throughout all of my Kubernetes clusters. These namespaces allow for you to separate them from a security standpoint. Think of it as multi-tenancy. And these, again, line up with those resource pools. Probably not going to spend too much time on this, but this is kind of bringing home that idea of, the separation between what I'll call a cloud admin and some sort of a consumer. It's a generic term for somebody who's using all your stuff. So We talked about the ease of install of the supervisor. Once that's unlocked, you have these various built-in services. We have a CSI, we have a CNI, right? Container network interface, container storage interface. Those are all, you don't have to set them up. They're all just simply included as part of the initial implementation of the supervisor. Whoops. Then, like I said, we have the supervisor services, stuff like Harbor and whatnot. We include REO CD and a workload capability there, or a CI/CD capability there. Notice that the consumer is really consuming all of this. We talked about the namespaces. We have storage classes. One of the things that I encourage a lot of vSphere engineers to get used to is this whole idea of policy-based management, which is a thing. There's a whole, like, you can look it up, you can Google it, but policy-based idea is, and this is kind of where people kind of get a little leery about, granting access for other people, because a lot of times people are used to like, no, I do this thing, I control it. It kind of scares me that I'm granting this to other people. Well, the work is front loaded where you define your policies, and those policies act as guardrails. And those guardrails now allow me to, like, okay, I'm going to limit based on these particular things, whether that's resource consumption, whether that's security, whether that's, certain quotas on storage and whatnot. These are all defined by those policies, and those policies state what people can do within that particular object. Once it's out there, and you let the platform do all the work. This is where, a lot of that automation, policy-based management aforementioned comes in. And I can't stress this enough also. If you are a platform engineer, if you are a developer and you're on this call, I was actually on with a customer 2 weeks ago. I was doing a VKS workshop with some of the content I'm actually doing here. They don't do UIs. They don't do them at all. No UIs. Like, everything is all infrastructure as code, pipeline, CI/CD aware. That's what we do with everything. I can't stress enough that our product has that ability from the get-go. You want to do CI/CD pipelines, you can do it all day long. You want to do GitOps, you can do it all day long. You do all of those things like you could at any other kind of, enterprise grade product. You can do that as well. So that's out there, and you have those choices. We do offer at least 2 UIs of which I am aware, one of which is in vCenter. So again, going back to our whole, like, hey, you've got vSphere now and you want to implement this. It's called the local consumption interface, and it is an extensible thing that you would install on top of the supervisor. Anytime you see this highlighted, it's to remind me of it. Because I always forget about the Cloud Init one, which you could do Cloud Init before, but we now have Cloud Init integrated into the product itself. And Cloud Init is a big deal because it is a pretty common methodology for setting up machines once you have them rolled out. It's kind of like bootstrapping their configuration. Once you have them, once the VM boots up, Cloud Init will then configure it for whatever it is you're doing, right? So it's kind of like a gosh, what's the old school thing that we had before? It'll come to me. But Cloud Init allows for you to configure those in an automated way, and it's yet another thing that people put in their CI/CD pipelines as part of that rollout. This is just bringing home that point, like, hey, YAML is YAML, man. Notice we have provide access through kubectl as well. So part of my point here is, this is kind of your all things to all personas. The other choice of interface, if you're running VCF, you have the capability of using VCF automation. Just so everybody's clear, that's Aria automation. Just so everybody's clear, that's vRealize automation, if we want to go way back. But VCF automation is the name of it moving forward. But this gets into, okay, hey man, I want to have a centralized sort of catalog-based methodology, not unlike you would see in the public cloud. I want to grant the capability of my developers or my platform engineers or my site reliability engineers to just click a button and roll out a Kubernetes implementation. That is what we are talking about here. And this is super important for a lot of our other platforms. We're going to start talk. There's going to be a brief nod to our AI platform coming up here. All of those things are ultimately built with VKS as the engine that drives all of this. So I have the capability of doing straight up kube cuddle if you want. I have infrastructure as code and the traditional sense. I have the local consumption interface, which is within vCenter. And then I also have the capability of using VCF automation in a catalog sense to be able to say, I want people to be able to roll out their Kubernetes clusters and lifecycle them through all of that as well. You can actually make it to where like, okay, you got a test Kubernetes cluster, it times out after 2 weeks or whatever. You can do that as well. All right. Myth 3 out of 4. This is yet another blog post I have, shameless plug. Comparing VKS to running on bare metal. And this is another big misconception I see out there. The main point I have for this section is that the difference between running things, quote unquote, directly on bare metal, there are basically different methodologies of what we mean by bare metal, by the way. So it isn't just like virtualized end-to-end or bare metal end-to-end. There are certain choices that you can make. GPU pass-through is one of them, for example, right? Versus virtualizing your GPUs through vGPU. But there's this whole like, oh, well, I run it on bare metal, it's advantageous. The difference between those two, between virtualizing your Kubernetes implementation and really I'm going to really kind of like put this within the context of AI, we'll call it. The difference between VKS or virtualizing a workload and bare metal is measured in microseconds. And we have some receipts on this as well, as you'll see. So we just mentioned the fact that most enterprises, including hyperscalers, run Kubernetes and containers on virtual machines. Performance is typically a non-issue. There's independent studies come out all the time, not just necessarily from us, quite honestly, who encourage the fact and state that, hey, there really is not a noticeable difference between the two. And again, my disclaimer here is I am not saying that there's never a good use case for running Kubernetes on bare metal, but I would say that, hey, you should be running Kubernetes on bare metal is an argument you could have if the year was 2017. There was an industry sort of battle back and forth, way back with the push for Kubernetes in the mid-teens, for example, to say, okay, well, should we run it on bare metal versus virtualized platforms? And virtualized platforms won out in a very, very big way. This whole idea that like virtualization is, somehow going to lead to different, noticeable differences in performance is like an idea that went out of style in like 2012, we'll call it. The hardware itself has been optimized for running on virtual machines. So your various hardware vendors have really closed the gap there. It's really kind of like saying we still run things on RDMs, for example. So a lot of you old school vSphere people probably know what that means. But ultimately, this whole idea that, I've got to run it on bare metal is just a big misconception. And I see this all the time. And, it's hard for me sometimes to be able to convince them because it's so ingrained. But, if you go out and take a look, and now that really that when we start talking about putting things out in the public cloud, it's all on VMs as well. This kind of whole idea of I've got to run it on bare metal. You're making things so hard on yourself as an organization and as an engineer to say, well, I'm just going to run it on bare metal. There's a lot of more administrative overhead that is usually just not worth, the juice isn't worth the squeeze. So Kubernetes on VMs are typically cheaper. So think about this. If I'm doing Kubernetes, straight up Kubernetes, we just talked about the fact that you get started within an hour. If you say, okay, well, I want to run, AI ML workloads, well, then you're looking at, maybe, augmenting your existing host with GPUs, for example. But bare metal typically you're required in a CapEx greenfield. So like I've got my vSphere, my VMware implementation, but I'm now going to go separate things out into a whole new set of hardware. You know what else is expensive? Hardware. So what would be the least expensive in that case, right? Scalability and management is easier. Supervisor Cluster we talked about can be provisioned pretty quickly. No change in needs for hardware scalability. vSphere Cluster redundancy, right? all the things that distributed resource scheduling, HA, the capability of doing this through stretch clusters, because we support stretch clusters in a lot of different ways. Those are all things that may already be in place, so that since these are all VMs, they are all protected in the same way without any additional configuration. You can leverage your current talent pool. So remember that since we can leverage our current vSphere talent, for example, or VMware engineers, since we talked about the fact that this is something that is very familiar to them, you can leverage that. You don't have to spend too much money on talent, for example. Can be managed by current infrastructure engineers, and since the VKS is conformant, Kubernetes or CNCF conformant, this is all stuff that they are pretty well familiar with. And then we have the capability of doing that multi-tenancy, not just through namespaces, but others as well. Very quickly, we support the capability of doing vGPUs. So, for example, in sort of your larger shops, we found that what happens is you have a set of data scientists who monopolize a set of machines that aren't allowed to be shared out by others. So you can virtualize your GPUs just like you can virtualize anything else, and this leads to a much more flexible implementation of the underlying GPUs in the long run. So just food for thought as far as those capabilities built into ESXi in the long run. Oh, okay. Coming down home stretch. I know I'm kind of pushing. We wanted to have some time for Q&A. I think we might actually be on track for that.
You're trying.
But one of the other,
you're rocking and rolling.
Okay, cool. Yeah, I think the timing's going to be good here. The other one I see is not considering VMware as a major player in Kubernetes or software development. And again, that is yet another thing that we have the receipts for. So number 3, contributor to the Kubernetes community. There we are. This is still true, by the way. If you go out to this source and look right now, this is not a doctored screenshot, but there we are. As far as Kubernetes contributor, we're right under Google and Red Hat right there in the list. There are a lot of CNCF compliant or open source tools that we have developed and then made open source, or they were open source from the beginning. That's Valero. We actually have other vendors who actually leverage Valero. Contour, Harbor, Entrea, Pinniped, which is for identity and access management. We were the first to use Cluster API, which is the recommended approach from the Kubernetes community there. We contribute to etcd, so we literally have line of sight and contributions into the Kubernetes implementation and have for a really long time. We have advocacy. We have a big presence at KubeCon. We continue to contribute to those Kubernetes CNCF implementations. Those runtimes are compliant with all of that. We have lifecycle management, by the way, which is independent of vCenter. So some of you who may have implemented our previous Kubernetes implementations, we've made it so that it's independent of that, so that you can continue to do the lifecycle independently. And then sort of a nod to our what is Tanzu. So a fun fact, Kubernetes runtime in vSphere is called VKS. Notice so far, I have not even used the word Tanzu. We'll have to go back to the recording and validate that, but there may have been 1 or 2 mentionings of it. But anyway, I don't think there is. So that's VKS. Tanzu is our platform as a service offering, and I'll probably give our good friend Christopher Katano a little bit of time to speak to that. But this would be sort of a catalog-based capability, database as a service, so data services. All of those are app runtime. This is going to be stuff like Spring. A lot of people don't realize it, but Spring is also a VMware thing. So if you're a Spring adjacent or you're a Spring developer, then you're aware of our contributions there. This is our private AI offering. You'll hear it referred to as PAIF, P-A-I-F. The full name is VPAF-N. Nice lengthy thing. Another myth that I'm busting for you here is, look, man, in a build versus buy situation, I totally get it. You've got to make that sort of decision. We're in sort of wild, wild west in, running AI on-prem that we were in the wild, wild west of running Kubernetes on-prem. So we kind of see that second wave of people coming in and, rolling out their AI engines. There are a lot of organizations and companies that we have as customers who are looking into AI simply because their competitors are looking into it, or their competitors are running it. So they have this sort of critical mass of like, hey, whatever my opinion is as a company is of AI, I need to run it. So a lot of those companies are still trying to figure that out, and that's what we're here for. And there's this misconception or this myth also that DIY is going to be the less expensive option, and trial and error is pretty expensive, man. So one of the things that we've offered through a partnership with NVIDIA is our private AI platform. This is an out-of-the-box offering that allows for not only, we've supported GPUs for, gosh, a decade at least from a hardware perspective. This allows for you to have a self-service. I've got data scientists who want to start running workloads. Again, with the standing up the VKS, because VKS is underneath the hood in all of this. I now have all of these things at my fingertips to be able to run all my models, all that I want to, all day long. And this is all based on a thing that is provided to you out of the box through we'll call it PAVE. Then we have our Tanzu portfolio. This is our platform as a service. Kind of have three pillars here. We've got our Tanzu platform. This is going to be a development stack. Super cool stuff. All of our customers who run this typically are huge fans of it. There's that. We have our data suite with our database as a service. And then we have our catalog, which is another thing that people typically become very big fans of. So from a platform as a service and a development stack offering, that is that. And like I said, I'll give Christopher Katano a chance to speak to that as well. You're like, okay, Bryan, you know what? Maybe you already have your own AI ML stack. Maybe you have your own development stack. Maybe you have your own development stack as well. Of course, we're going to, advocate for our own. But I'm also going to say that it's a reality that we want to meet you where you are. And I can show the receipts on this one too, keeping a customer anonymous. But we actually had a customer who's like, you know what? We want to keep our dev stack as is. By the way, they were running out in the public cloud, but they're like, I want to keep our dev stack as is and just realign it with VKS locally. And they're able to do this successfully for a bunch of different reasons. Again, I'm going back to the whole idea that our implementation is a CNCF certified and standards-based offering through and through. So you might be thinking, well, Bryan, we already have a bunch of stuff that we already use. We want to switch it to VKS. And by the way, you can do this through coding standards. For example, kind of the whole point of Kubernetes is the ability to parameterize all of your things and be able to realign them with a Kubernetes cluster anywhere. That is ultimately the goal. If you read up on the original intention of what has now become Kubernetes, what became Kubernetes is I need the ability of doing this in a way that's standardized that I can realign. Not saying it's going to happen overnight. I'm not saying it's effortless, but just keep in mind that if there are certain things that you prefer and that you're using now, these are just some of the things, and this is including but not limited to, these are just some of the things that I thought of. These are things that I thought of that, hey, if you're using all of these things, you can actually realign those and run them on-prem. And again, this is yet another thing that people say to my face. Oh, well, we're using Azure DevOps. Well, did you know that there's an on-prem version of Azure DevOps? You can do that on-prem as well. And this is yet again another thing that, we need to make that case typically to people who are making a lot of these decisions at these various organizations. Like, hey, we can do this too. These are things that we do day in and day out, and we deserve a seat at the table. And these are things that we can provide. So last part, and this I will turn over to our good friend, Mr. Katano. Hopefully you're still, look at it, he's coming on camera. Awesome. Is okay, you've been sold on it. You're like, hey, Bryan, I'm picking up what you're putting down. What do you do next? So Chris Katano, the floor is yours.
Hey, thanks, Brian. Appreciate it. Great content. Yeah, so really, the important thing is how to get started. There's a lot of questions that I've seen in the chat as well as in the Q&A over there, kind of spanning really deep technical questions all the way up to kind of, more community questions and business unit questions. So anyways, I think there's a good alignment here with being able to help everyone out there understand how they can get up to speed quickly. So on the left, where you see resources and self-paced content, that is easy. That is for you to take at your leisure to be able to look at and understand the design resources, the documentation that are out there. I recommend doing some of the hands-on labs. They are a great way to actually go see, look and feel the product, kind of get yourself immersed. And it's a great learning path. You also get to understand what it takes to turn it on. As Brian was mentioning, how do you get started and what do you got to do to the environment? It walks you through a lot of that. So you can do a lot on your own. We can also have a demo or a deep dive with you where we can come in and talk about, once again, a lot of the questions are around VCF and VKS. We can go just into VKS. There's an account team for you specifically that you'd be able to go out and engage to have these conversations. And then depending on the commitment and the partnership and the level of effort, we can actually sit down, we can do a workshop where we can baseline and understand your current path to production, your workflows, capture your timelines and goals, and help you build a roadmap where we can then build an architecture and attach that architecture based on your requirements and help you build your VCF environment to be able to be successful. And then obviously on the far right, if you want to buy the outcome, obviously there are things that we can do together where we can partner with selective partners as well as services that we have to be able to actually help you turn it on in a very paired manner. So again, level of effort on the left is the easiest. On the right is the complete outcome delivered, and anything kind of in the middle based on your desire, your intrigue and timelines this is a good opportunity here.
Looks like just like 3 minutes left. There's a burning question, I think.
If I read the tail end of it.
Yeah, what's the burning question? Let's hear it.
The burning question is, can you discuss Lifecycle briefly? When new releases, cadences, the deprecating of support, what are best practices, rolling upgrades, how you build new clusters, tear down old ones?
Yeah, it's a really good question because the Kubernetes release schedule is for years been pretty aggressive. So a couple things that we have done and that we'll continue to do. The first, I probably don't have the time to switch out the slides, but by the way, anything I'm saying, I will do this. Let me go back here. Here's my email. So if there's anything that, if I don't know the answer, I can always send this off to people like Chris Katano down there. But one of the big things is we've done this for a very long time. We've made a huge amount of improvements with that 8.0 U3 release. One of them is I want to upgrade the supervisor cluster. So that's part one, right? I want to upgrade that. It used to be tied to vCenter, so you'd have to upgrade vCenter first, and then you could upgrade the supervisor. No longer the case. So you can upgrade the supervisor cluster independently of that. One of the things that as far as your end user Kubernetes clusters, right, the end user ones, there are three possible, and I'm going to do this from a worker and control node question and answer here. So, for example, all of these worker and container node or controller nodes in my Kubernetes cluster run in VMs, and they have to run on an operating system. The two that we have that we distribute and support are Photon OS and Ubuntu. There is also a third one, which is you can bring your own as well. But I've pretty much found that the two that we have with the Photon OS and the Ubuntu, implementations, those for your worker nodes and your control nodes, are pretty much the 95% of what people will use out there. Those are optimized for Kubernetes. Those are built to work with, because remember with those images, you want them to be very, very special use case. We want them to serve out containers. So we want those lean and mean, and that's what we have. As far as the lifecycle built therein, the local consumption interface allows for you to iterate on those versions as well. And remember, with the self-service, you have the capability of rolling out or decomming those Kubernetes implementations as well through either infrastructure as code or through those particular interfaces. Hopefully, I answered that question. But if there are any more specifics, then you can certainly email me.
Absolutely, and I provided your contacts for him in the chat on the Q&A. Thank you
Cool.
guys all for attending. This is an amazing session. We are finishing on time. We appreciate you guys being here.
You're
and
welcome.
Be sure to join us next month on our next webinar as well as the webinar that I dropped there in the chat. You guys have a wonderful rest of your week and happy good days.
Thanks, everyone.
Thank you.